Okay, guys, let's go over this unit of equations and inequalities. And we're going to start out with solving equations. Remember, you may have to provide the reasoning. So our first example, we have to distribute. So I'm going to distribute 3/4. So this is saying 4 into 12x is 3x. 3x times 3 is 9x. 4 into minus 8 is minus 2. Minus 2 times 3 is minus 6. 1/3 distributed 3 goes into 27x. 9x times 1 is 9x. 3 into minus 15 is minus 5 times 1 is minus 5. Now, here's where so many folks miss the mark. When you have variables on the left and the right, deal with the variables first. Address the variables, not the constants. Typically, we say we're going to subtract or get rid of the smallest variable, but these are the same. So we still are going to subtract them out because we can't have variables on the left and the right. And when we do that, the variables are eliminated and we get a false statement. So we say there is no solution to this equation. No value will make the equation true. Now let's take a look at this equation. So the problem is the given, and now before we can move on, we have to distribute on the right side. And this time we have to double distribute. X times x is x squared. X times minus 2 is minus 2x. Now let's distribute the positive 2. This gives us plus 2x, and this gives us minus 4. The middle terms we're going to combine, and we have x squared minus 4 on the right. Now, we can see that these equal each other. There's going to be infinite solutions, but go ahead because you may be asked to provide the final math statement to prove your solution set. So again, we're going to address the variables before we address the constants. So we have an x squared on the left and an x squared on the right. We are going to subtract those out, and we have no variables, but we do have a true statement. So we have infinite solutions, meaning any value in the world will make this equation true. The left side will equal the right side no matter what value we use. Okay, we're solving for x. We don't have variables on the left or the right. We're just straight up solving. We have x squared plus 25, so we are going to subtract out the 25 and we get negative 25. We're going to undo squaring, which is taking the square root, and we need the positive and negative. Now here, let's hold up. You cannot take the square root of a negative number. There is no number multiplied by itself to give you negative 25. So we are going to say no solution because there's no value that if I put in for x that will make a true statement. If you said the answer was negative 5, negative 5 times negative 5 is 25. 25 plus 25 is not 0. So there is no solution for this equation. Okay, let's take a look at this one. It looks very similar, but it's different. So we're going to undo the subtract first. So we're going to add 25. So it's making that 25 positive this time. We're going to undo squaring by taking the square root, plus or minus. This undoes the squaring. So we have x is equal to positive and negative 5. So we have two solutions that would make this equation true. Okay, this time we have two expressions, two binomials that we do have to expand. This goes back to our previous unit. So be careful with distributing. So on the left side, we're going to distribute the x. We get x squared minus 4x. Now let's distribute the negative 4. We get negative 4x plus 16. Let's distribute on the right side. Let's start with the 4. We get 16 minus 4x. Now let's distribute the negative x. We get negative 4x and positive x squared. So let's combine. So we have negative 8x plus 16. I'm going to write this in standard form, meaning let's put the x squared first, combine the middles. We can see that these two expressions are equal. We're going to have infinite solution, but let's go ahead and let's combine or get rid of the linear term. So I'm going to come up here. We have x squared minus, whoops, is positive 16 equals x squared plus 16. Now let's cancel out the quadratic terms and we get 16 equals 16. We have infinite solutions. Okay, let's solve this one. X is being squared, then multiplied, then subtracted. So we're going to undo going backwards. So we're going to add 75 to both sides. We are going to undo multiplication by dividing. We are going to undo the squaring by taking the square root. Don't forget your plus or minus. So that undoes the squaring. And my two solutions are positive and negative 5. So we have two solutions. Okay, let's solve this equation. X is being squared, then multiplied, then subtracted. So we are going to add. And we have negative 3x squared equals 75. We're going to undo the multiplication by dividing by the negative 3. We get x squared is equal to negative 25. When we take the square root of both sides, we notice that we're taking the square root of a negative, and we cannot do that. So we're going to say there is no solution to this equation. Okay, let's try this equation. Very similar to the past few. So we are going to subtract. So we're going to use the subtraction property. And then we're going to use the division property of equality. Then we're going to use the square root property of equality. And again, we can't take the square root of a negative number, so there is no solution to this equation. Okay, let's try this one. We're going to bring down negative 3x squared equals negative 75. We're going to use the division property of equality. We get x squared. This time we get a positive 25. So when we take the square root, we're taking the square root of a positive number. And we do have two solutions of positive and negative 5. Whoops. So two solutions. Okay, we are solving for x. X is being squared, then multiplied, then added, then divided. So we're going to work backward, and the last thing we're going to undo is the squaring. So first, we have to get rid of this divide by r, and so we multiply both sides, and this is just q. It's not q plus anything or minus, so I don't have to use parentheses because it's a single factor here, a single term. And now we have 3x squared plus k is equal to qr. Again, we're solving for x. We're going to subtract k. Remember that the q times r is already there, but so it goes out in the front. So it's qr minus k. Now we're going to undo multiplication by dividing. We get x squared is equal to qr minus k divided by 3. We're going to undo the squaring by taking the square root of both sides, so plus or minus out front. And our final answer is x is equal to plus or minus, and all of this one term is under the radical. This time we are solving for x again. It looks like the same problem, but we have a minus w. So we have two terms. we have this big term and this single term. So we're solving for x, so we need to get rid of the minus w first. So get rid of any terms that does not contain the variable we're solving for first. So again, the q was there first, so the w goes behind plus w. We are going to undo division. Now this time we do need parentheses on both sides here. I'm going to put my r out front. That cancels. We have 3x squared plus k is equal to r times q plus w. Do not distribute the r. Now we need to undo the plus k, so the minus k comes all the way at the end. We have 3x squared equals r times q plus w minus k, and now we're going to undo the multiplication, divide by 3. So we have x squared is equal to r times q plus w minus k, all divided by 3. Last step, we need to undo the squaring by taking the square root. We do need the plus or minus and the square root symbols over the entire expression. So x is equal to plus or minus. We have r times q plus w minus k over 3. So make sure this entire term is under the radical. Okay, let's go over some inequalities. We are going to be solving for x and then graph it and write it in interval notation. So this is compound, so we're going to isolate x in the middle. So we're going to subtract 4 from the middle and the left and the right. We have negative 12 is greater than negative 2x, which is greater or equal to negative 16. We're going to undo multiplication by dividing. Now, look, we are dividing by a negative. We have to flip-flop both inequalities. So this gives us 6 is less than x is less than or equal to 8. So we are going to graph before we write it in interval notation. This graph helps me so much when I am trying to write interval notation. So x, if we read it from right to left, which we typically don't do, but x is greater than 6. It's open and shaded to the right. And it is equal to 8 and less than 8. So it's sandwiched in between 6 and 8. 6 is not included, so we need a parentheses. And remember, your comma represents the shading. And then we have 8, and then the closed circle means it is included, so it's a bracket. So when we have the half of the equal sign, we have a closed circle, we have a bracket. When we don't have an equal sign, we have an open circle and a parentheses. Okay, let's solve this one. We are going to simply add 2 to both sides. We get 8 times x is greater or equal to 0. Keep going. Don't think you're like it can't work or you're stuck. We're going to divide, and x is greater or equal to 0. Remember, 0 is a value. You can have 0 as a solution. Okay, so let's graph this. So x, my possible solutions, are equal to 0 or they're greater, any of these values. So when we're doing interval notation, we look at the graph and we go from left to right, and the shading begins at 0. It is closed, so we need a bracket. We have the comma for the shading, and then it goes all the way to positive infinity, which we never use a bracket. It is parentheses. Okay, this time our variable is on the right. I'm going to solve it as is, and then I'll flip it around in the end to put my variable on the left. So we need to undo the addition, so we're going to subtract. Now we're going to undo division by multiplication. So we're multiplying. I have 20 is greater than x, or I could say x is less than 20, so I'm going to flip it around just because I prefer it that way. We are going to graph this so we can do interval notation. So 20 is not part of the solution. It's our boundary number. X cannot be 20. It can just be less than. And so now when we do interval notation, again, we start wherever the shading starts, going from left to right. So negative infinity is where the shading begins, and then it goes all the way up to 20, but does not include 20. So it's parentheses. Okay, here's another one. Let's simply add 10 to both sides. We have x divided by -4 is greater or equal to -2. Now we have to undo division by multiplication, and look, we are multiplying by a negative, so it's another flip-flop. If you multiply or divide by a negative, you have to reverse the inequality. So now we're going to graph this. Our boundary number is 8. 8 is part of our solution, so we shade it in, and then we shade to the left. So when we write this in interval notation, again, we're going to locate the shading, and it begins at negative infinity. Negative infinity is always going to be on the left side of your interval notation, just like it is on the number line. And then it goes all the way up to 8, and 8 is included, so we need a bracket. Okay, let's take a look at this one. This is a compound. So we have 8 minus 4x. So we have to remove the 8 first. So we're going to subtract 8 from all sides. This is 4 is greater or equal to -4 times x is greater than 8. We're dividing by -4. So that's a little flip-flop. So this gives me -1. We're going to reverse the inequality and reverse the inequality. And now we're going to graph this. Let's see what this looks like. Okay, now -2 is here and -1 is here. So let's just do this carefully. So x is less than -2, and it's not included. X is equal to -1. So x can be less than -2, or it can be equal to -1 and greater. So when you write this in interval notation, do not look at this inequality. Look at your graph, because you're always going to write it from the least to the greatest. So I'm starting, and the shading begins at negative infinity. It goes up to -2. It's not included. We have this gap, so we're going to say union, and then it picks back up at -1, and -1 is included. And then we go up to positive infinity, and then we need parentheses. So when you're writing interval notation, ladies and gentlemen, please use your graph. And know that even though the -2 was on the right side in the situation, in our inequality, when you graph it correctly. Okay, here's one where we have an or, and it's two different problems. So we just solve these independently. So on this first one, we're going to add 6 to both sides, and we get -6x is less than or equal to -30. We're dividing by a -6, so I'm going to flip-flop this around, and it becomes x is greater or equal to +5. Or, and now let's solve this inequality. So compound just means we have more than one inequality graphed on a number line. We're dividing by a positive, so we leave the inequality as is. So negative infinity, positive infinity. So we have a 3 that's going to go on the left side of our number line, and 5. So x is less than 3 and not equal. Here we have x is equal to 5, and it's also greater. So we're going to graph, we're going to do our interval notation. So we start on the graph going left to right. So we have negative infinity, comma 3, parentheses, union for the gap. And then, oops, we need a bracket here because it is included, okay, right here. And so we have 5, comma, positive infinity parentheses. Okay, let's do a few word problems. So we're dealing with perimeter of a rectangle. So our formula, it's always important to write your formula. And we know these because we've been studying these for a while. So I always like to make sure that I use parentheses. And then we have a length that we will represent with an algebraic expression. We have a width. And then we'll take those expressions to plug into the formula to write our equation, if I can spell equation and talk at the same time. The length is 12 less than 4 times the width. We know nothing about width, so let's let X stand for width. Less than is a flip-flop, so we're going to flip these around and say 4X minus 12. Now, here, ladies and gentlemen, this is where if somebody misses it, they forget to bring the 2 down. So we're simply using the formula. So we have 2. Instead of length, we're going to use our algebraic expression for length plus 2 times width, which is x, equals 126. We're going to distribute 8x minus 24 plus 2x equals 126. We're going to combine like terms and we get 10x minus 24 is equal to 126. We're going to add 24 to both sides and we get 150. We're dividing by 10 and x, which we defined as the width, is 15. To get the length, you plug it in for x. We know x is 15. 4 times 15, that's going to give us 60 minus 12, that's going to be 48. So our length is 48. Case earned a 90, 86, 84, and a 92 on his math test. He wants an average of at least 90. So we have 90 plus 86 plus 84 plus 92 plus the next test. And when you take an average, you divide by how many elements are in your set. So we have 1, 2, 3, 4, 5. And we want the average to be at least a 90. Okay, so I have the average equals the 90. Here's our formula. Now we have to combine like terms. So I'm going to take my calculator. 90 plus 86 plus 84 plus 92, and we get 352 plus the x divided by 5 equals 90. So we're solving for x, the grade that we want to make, so that we will have a 90 average in the class. So we have to undo the division first. So we multiply both sides. That gets rid of the divide 5. And we have 352 plus x is equal to 450. Now we just have to subtract out the 352 to isolate the x. And x is 98, so he needs to make a 98 on the next test. Okay, now here we have an age problem. So we have the formula, we have Joni, we have Robin, and we have Lori. And then we're going to have an equation. So our formula is going to be Joni's age plus Robin's age plus Lori's age equals 107, okay? So the sum told us our formula. So Joni is 10 years less than twice as Robin. Lori is 12 more than half as Robin. So we know nothing about Robin, so that's what our variable x is going to be. So let's use x to write Joni's expression. Joni is 10 less than, so we're going to flip it around, twice Robin. So that's 2x minus 10. Lori is 12 years more than half as Robin. So we're going to flip that around and put half x plus 12. Now use your formula to create your equation. For Joni, that's 2x minus 10 plus Robin is x plus Lori is 1/2 x plus 12, and that equals 107. We're going to combine 2x, 1x, and half x. So that is 3.5. We will convert this into a improper fraction in a minute. And then we have negative 10 and positive 12. So that's plus 2 equals 107. We're going to subtract 2. I'm going to convert this. 2 times 3 is 6 plus 1 is 7 over 2x is equal to 105. To undo multiplication of a fraction, you multiply by the reciprocal. The 7's cancel, the 2's cancel, x equals 7 divides into 105 15 times, and 15 times 2 is 30. So Robin is 30, where Joni is 2 times the 30 minus 10. So that's 60 minus 10 is 50, and Lori is half of 30, which is 15 plus 12, so that makes her 27. So those are their ages. Now let's do a couple of consecutive numbers. So our formula, it says the sum of 3 consecutive numbers is 267. So we have 3 numbers combined together equals 267. The word consecutive means in order, like 8, 9, 10. That's consecutive. So our first number, we're always going to let be x. Okay. So the second number, so if these were our numbers, they're not, it's not, but if these were our numbers and 8 was x, what would we do to x to get to 9? Well, we would add 1 to x. So our second number is x plus 1. If 8 is x, what would we do to x to get to 10? Well, 8 plus 2 is 10, so x plus 2. Now we're going to plug those in. So our first number is x, our second number is x plus 1, and our third number is x plus 2. We're going to combine our like terms, and then we're going to solve. We're going to subtract out 3, and we're going to divide by 3. Okay, and then when we divide this out, our first number, 264 divided by 3 is 88. So we have 88. 88 plus 1 is 89, and 88 plus 2 is 90. So these are our 3 consecutive numbers. Now let's do one that's similar, but this time the sum of 3 consecutive odd numbers. So we're still going to have the same formula, which is a first number plus a second number plus a third number. And again, the word sum tells me to use plus. And we still have x being our first number. But let's think about this. Okay, so 3 consecutive odds. So that's like 3, 5, 7. So if x is 3, what are you going to add 3 to get to 5? Well, you're going to add 2. So our second number is x plus 2. What would you add to 3 to get to the third number of 7? Well, 3 plus 4 is 7. So that's the expression for the third number when we're skipping a number. Even if it were 3 consecutive even numbers, this would still be how you would set it up. So we have our first number x, our second number x plus 2, our third number x plus 4, and it all equals 1,209. Again, we're going to combine like terms. 3x plus 6 is equal to 1,209. Subtract out your 6 and divide by 3. And so when we divide this, and I know we can easily divide it, and so we get 401. So our first odd number is 401. Our next would be 2 added to that, 403, and then we would get 405. And I hope this helps you.